Okay, then just only a short topic. Then some of the notes also related with the chemistry lah. I think there's a no problem for yours because the sum is a proton number and also the neutron number. Okay, so we go and see this one. Okay, this one topic is totally with different with the others. They got person independence one. So that means any formula that's not related with the in front. So this one is an independent, so we can go through this topic and finish it. Okay, so now we go and see what means of the radioactive decay. Okay, this is one of the process. Okay, process to which unstable nucleus. Okay, they will happen when the nucleus is unstable. Then after the decay, they become more stable. Okay, when they become more stable, they will come out something. Okay, the something we call radioactive radiation. Either is alpha, either is beta, either is gamma. So these three things, we call it as a radioactive radiation. So the whole thing we call radioactive decay, the one of the process to make an unstable nucleus become more stable. When they just become more stable, they will emitting some of the radioactive radiation. So either alpha, either beta, either gamma, or mix together also can. So now we're going to see the next one. So this one example diagram. So this one is an unstable. This one we call unstable nucleus. Normally we call it as a parent. Parent is unstable. So after that, they will do the radioactive decay. Okay, they decay, they will produce the daughter isotope. Okay, they produce the daughter. After that, they will come out. Sometimes it's alpha, sometimes it's beta, sometimes it's gamma. So three we also need to learn. Then after learn the three, I will mix. Okay, then we do some calculations. Okay, so from here, we're going to start to introduce first. Radioactive decay will happen. Okay, this one you need to know. Random and spontaneous. So that means we cannot say, oh, today must happen. Tomorrow must happen. No, they will happen random. We also do know, we only can assume this range lah. They will happen around this month. But which day we still don't know. Okay, they got spontaneous, rawak. That means they cannot say or fixed one day. Okay, then after that, number two, three types of the radioactive radiation. So just now I mentioned. Okay, first one we call alpha. Okay, this one alpha particle, you can call it as a helium. Okay, actually they just represent by helium, 4 nucleon number, 2 proton number. This one is when I just write the formula for the alpha particle. This one is a symbol, alpha symbol. They're just like the directly proportional, but this one is an alpha lah. Okay, number two is a beta. Beta actually is an electron. There's a negative electron. And this one is a beta. And the last one should be the gamma. Gamma ray. You know the gamma ray lah. Form 4, we learn about the wave. This one is a gamma ray. Okay, so this one is a 3 of the radiation, radioactive particle that we produce after the radioactive decay. Okay, now we go to introduce one by one. Okay, first one we call equation for the alpha decay. So that means we just fix only alpha come out. Okay, when only alpha come out, we need to write the equation. How to write the equation? Okay, alpha particle, we can call it as a helium nucleus. Okay, another name for the alpha, there's a helium nucleus, which consists of the 2 proton and 2 neutron. So normally you just write, this is a neutron number because you have 2 neutron, 2 protons, so they become 4. Then proton number only 2. So this is a symbol for the alpha. So from here, example, the parents. Okay, this one we don't know lah. I do know lah. Maybe you know lah. Pu, what is that? You learn about your chemistry. So then from here, the starting the neutron number is a 240, and the proton number is 94. After decay, they come out the uranium. Okay, become 236. You can see the neutron number. Neutron number, the last 4 already. The last 4, that means they come off the helium. So suppose we need to know when before decay, the neutron number must equal after decay the neutron number. So that means 2, 3, 6. So 1 is a helium, 4 and 2. So after plus together, that should be same like the original. So you can see the proton number also same. Pu is a 94. After decay, become uranium is 92. So that means they come out something. The come out something is a alpha. So there's a 2. 92 plus 2 become 2. So the question how to come up, there may be, they never write the alpha. They just show you the uranium. Then they ask what they produce. So you from the proton number, from the neutron number, so you can guess, or this one is alpha or beta. Because beta electron is a 0, -1. So electron, there's a not related with the neutron number because there's a 0. So neutron number when changes sure is not related with the electron. They must related with the alpha. So this one, first one we call alpha decay. Maybe they can come up more than one alpha. We don't know. Depend the situation. If starting 240, 94. After that they come out this new uranium is a 232. Also can 232. That means the difference is a 8. 8 that means got 2 alpha already. So this one we just learn the basic one. Only one alpha to produce. So from here this one we call alpha decay. Okay, how to write the equation? We got so many patterns. Now we can see how to write the equation. Okay, first one they go to explain for you. Okay, unstable nucleus, they will release alpha particle to become a more stable nucleus. The more stable, normally we call it as a daughter nuclei. Okay, now we write the equation. You can see the first one. X is stand for the element. A is a nucleon number. Z is a proton number. So if you come up one of the alpha, that means helium. So the nucleon number need to -4. Then the proton number -2. So just simple. Okay, this one you learn from your chemistry. Okay, if you want to write more detail, actually this one alpha, we can write like this. So that means the equation you can say Pu 240 94. Okay, after that become uranium 236, then 92. Then plus you can write like this also can. But I don't suggest you write like this because like this we no need to write the proton number and neutron number. Better we write like this. Helium, then you write 42. Then we understand. Or proton number how many, neutron number how many. So you can see very clear. Okay, so this one is an alpha particles. Okay, now we're going to see the diagram again. We've got one more Ra 226 88. Okay, when they just decay, they become daughter. The daughter is a Rn 222 86. That means they come out one of the alpha. Helium 42. So from here, the parent nucleus has proton number Z. Okay, and also the nucleon number is a A. After just decay, you take the proton number, go to -2. Neutron number, you go to -4. So we just write the equation. Okay, so this one is another pattern you can write lah. Okay, so better we write this one number 1. Number 1 is more clear. Okay, some you also can write this part. Put the alpha here, then straightforward, this one is a Rn. So we got 3 methods how you write the equation for the alpha decay. Okay, everyone also same lah, beta, gamma also same. So this one just let you to know, sometimes the question come out like this, somehow they come out like this, so you need to understand what means of the alpha decay. Okay, so I think this one simple for you. We just need to know is later A, this one you need to fill in, this one need to fill in. The element we no need to memorize, because we also do know when they want to come out Rn or come out from the Ra. We also don't know. Just important is the proton number and neutron number. Okay, so you can see this one is a full lah. Better we write this one. This one is a full of the equation from this one, radioactive decay. Okay, then we go to second decay. Second decay is a beta. Okay, now you can see the beta decay. Okay, one of the things you need to memorize what means definition. Sometimes they will ask one. Definition for beta, this one is a definition. Beta is a fast-moving electron. Okay, so we can say there's a negative charge of beta. Okay, fast-moving electron. Okay, beta is a neutron. There's an unstable nucleus decomposed into the 1 proton and 1 electron. So suppose it's a proton number affected. Neutron number is not affected by the beta. So from here you can see Okay, this one is 1, 0. Then after that, 1 proton, then plus about electron. So normally the resulting from the proton remain in the nucleus while the electron is emitted with the high kinetic energy has beta particle. So another characteristic for the beta particle is a high kinetic energy because there's an electron. Electron, the charge is very small. So that's why when the charge becomes small and also the particle becomes small, they can move very fast. When they move very fast, you can say high kinetic energy. Okay, so from here, remember the alpha, they don't have any proton number, neutron number. They only got proton number. So this one proton number with there's an electron, -1. So from here, the neutron number, they don't have proton, they also don't have neutron. So that's why we put 0. Okay, they only got negative, there's an electron. Okay, so from here, this one is an example, carbon. Okay, carbon is a 14. After decay become nitrogen, so come out one of the electron. So from here you can see the starting X, AZ is it. This one is a original parent element. When it just decay, beta decay, you see the A, no changes because you come out 1 electron, then the electron also nothing for the neutron number. Okay, how about the proton number? Your proton number, because electron, they will -1. Okay, this one -1, they must plus back. You must plus again 1. So finally, your answer is a Z. So we can write the equation like this. Z equal Z plus 1 minus 1. So finally becomes Z lah. So at the top one is nothing happened. A equal A plus 0. Then there's still A. Okay, so the electron is more easier to guess it. When you see neutron number is no changes, sure they come out is an electron. Okay, if the proton number got changed lah. Okay, so from here, this one is a keyword lah. This one when I circle, then this one is a particle they produce. Okay, we call beta particle. Okay, now we can see the process. Okay, first one, carbon to nitrogen is it. After the beta decay, the proton number of the daughter, okay, this one nitrogen is a daughter, that becomes Z plus 1. But neutron number A, no changes. Okay, there's a no changes. How to write the equation? Okay, like this. Okay, if I put carbon, 14,6. When I become nitrogen, this one automatic, you need to plus 1. Because here -1. Okay? I free baru see. Okay, silang. Okay, so from here, if you write beta, you no need to put, we don't have like this. This one wrong. Other. We only got this one. When you just put beta, you no need to write the proton number and neutron number. Okay, so this one is another one. You just draw the arrow longer, then you put the beta here. So better we write the first equation. This one is more easier like you to see how the changes. Okay, so this one is the final, the equation for this process. Okay, so this one is a beta decay. Okay, now we're going to see the last one. The last one is a gamma decay. Okay, gamma actually we cannot see got any changes. Remember the gamma is no charge. If no charge, that means neutron number, proton number also don't have lah. The only is a one of the electromagnetic wave. So this has a definition for the gamma. When they just ask you what means of gamma ray, your answer gamma ray is an electromagnetic wave. Okay, so from here you can see gamma ray decay. Unstable nucleus release excess of the energy to become more stable. So that means when gamma decay, we cannot say got anything. No alpha, no beta. Only got gamma. We only can say the daughter, the parents, only less the energy or less some mass become daughter. Then they produce is gamma. So that means they don't have any changes of the charge. They only less mass or less energy. So from here, that means they release more energy, they become more stable. Gamma ray have no mass. Okay, no mass and also neutral. So they just change another shape. So from the parent, they change another shape for the more stable nucleus. After that, they produce energy. This one energy is a large energy. So from here, mass no. So just now we mentioned mass is it. So no mass. don't related with the mass. So the parents can become the daughter, just only produce large energy. Okay, if for the gamma ray lah. Okay, changes for the charge, no. Changes for the mass, no. They only make the nucleus become more stable. Okay, if gamma, actually we cannot see anything because you see no changes. A become A, Z becomes Z. Okay, if they produce gamma, they never call you to say, oh, now what they produce, we also cannot put gamma one because no changes. So gamma, normally they never ask you. They never ask you what the particle they produce. Unless no changes, baru they ask you, oh, this one parent, then become this one daughter. Then they see the proton number, neutron number, no changes. Baru they go to ask you, this one, what they decay, then you mention gamma ray. Because we see no changes. Okay, if the question got changes about proton number, then you need to do the calculations. Gamma is no need to do any calculations. Okay, so this one we call gamma ray. Okay, we write the equation. First one, the radioactive nucleus in excited state. Okay, nucleus with less energy. So from here you see after gamma decay, there are no changes in the proton and number and also neutron number. The nucleus is less energetic after the gamma. So that means this one parent is very energetic. Okay, after become the daughter, because they lost the energy. Okay, the energy lost already. So this one become less energy for the daughter. But the gamma is a gamma ray. Okay, we only know the energy loss, but we don't have any charges changes. So we write the equation. You see nothing one for the gamma. Okay, because gamma is totally don't have any charge. So we cannot see the proton number and neutron number. So A and Z, nothing happened. So this one we call gamma ray decay. Okay, seldom the calculation never come out for the gamma. Only the structure question and they ask you what happened. When this one change to this one, then you need to say gamma produced because they don't have any changes of the proton number and neutron number. Okay, so this one is the answer for the third one, gamma ray. So we mentioned just now alpha, beta, gamma. Now we need to see decay series. Decay series means when the parent become daughter, but the daughter still not stable. So the daughter want to decay again, become granddaughter. So that means there are so many steps. So when they do so many steps, that means one process can come up more of the alpha, more of the gamma. So this one we call radioactive decay series. Okay, this one is a explanation. When an unstable nucleus decay, the resulting is a daughter nucleus may also be unstable. So the daughter also unstable. So if the daughter is not unstable, they will continue to do the decayation. So from here, the daughter nucleus will continue to undergo the series of successive decay until stable configuration is achieved. So they will repeat and do until they become stable, then they will stop. Okay, so this one we call radioactive decay series. So that means the formula sure is very long because you do so many times. So from here you can see during the radioactive decay, some nuclei can emit so many reasons. Okay, can emit more than one radiation. So you can see example. Okay, uranium become TH. Okay, they can come out helium, they can come out gamma. So more than one. So this one is an example. This one you see decay series. So many times. Uranium 23892 come out one alpha, become TH 234. This one also unstable, continue to decay PA. Then you see PA. Oh, this one 90, this one 91. So neutron number no changes. So one alpha, one beta. Then after that they continue again. Another uranium come out. This one also unstable. Produce one beta. Then continue until the last one. Last one they say okay, RA becomes stable. Then they stop. So the question how to ask you? They're straightforward to show this one and this one. They ask you uranium become RA. They give you proton number, they give you neutron number, and they say, the process produce how many alpha, how many beta? The question is this one. Not the simple that just now, one alpha come out, one beta. No. Now it's a mix. So from here, they will give you the in front, the original, and the last one. Then they just ask you the whole process, got how many alpha and how many beta. So you need to do the calculations. So this one is a question normally they come out lah. So later we got some example question is like this. Okay, now after that we go and see what means of the half-life. Okay, half-life means time taken. Okay, the time taken for the activity radioactive to decay become half of its original activity. So this one is a definition. This one also every time you ask what means of the half-life. So remember, half-life is the time taken for the original object, okay, to become half. Okay, so example when starting 100%, okay, then the half-life will become 50. This one we call half-life. So you need to find time taken for 100% to become 50% is how long. So this one we call half-life. You need to find out. So remember, every time the time taken we need to find is when they just become half. 25, then become 12.5. This one, every time the half, the time taken is how long. When you find the first one is a 3-hour example. So every one, when you just divide by 2, everyone also is a 3 hour. So the question will say, when original is 100, when I just decay until 12.5, I left 12.5. So I do how many half-life? You do 1, 2, 3, 3 half-life. Then they say 1 half-life is a 3 hours. So total time is how many? 9 hours. So just a simple question. You need to just show about the range, the process. Don't need to do any formula. Okay, so from here, this one is a half-life. Now you can see after 1 half-life, the number of the nuclei are not decay will be half of its initial value. So that means after 1 half-life, the original will become half from the original. So that means 100% will become 50%. The 50% means what? The 50% is not yet decay. When I continue to decay, they become 25%. That means 75 already decay, hilang already. Only left 25% stay. Okay, if you continue to decay again, that means you only left 12.5. Okay, 77.5. 87.5. So minus you go to minus 100% minus 12.5. The left already decay. So that means you need to see the question very careful. Sometimes the question to tell you this one number is already decay. This one number is not yet decay. So you must be careful. Okay. So from here, this one they just tell you half-life is every time they make it become half. You take the time taken, that one we call half-life. Okay, so this one is an example. So you can see when starting uranium, then become this one. This one we don't need memorize one. Later I show you the simple one. This one is a too long. For the decay series, you see so many things. Decay series, they continue. Last one, stable. PB, problem. Okay, this one is an example. Decay series from the uranium become the lead. Okay, so we go to the next one. Okay, the trap of the uranium-238 will be decay eventually from the lead-206. So they explain for you. Okay, the grounding rock contain of the uranium radioactive isotope. The uranium nucleus, they undergo the radioactive decay to become the daughter. Daughter is a lead. So from here, the grounding for the rock after decay. So that means they take long time. Okay, when starting only uranium, after decay, they can mix. The lead go in. So you want to make until the uranium all finished, you need to take a longer time. So from here, by determining the ratio of the lead-206 to uranium-238 in a rock sample, the age of the rock can be estimated. So when starting, there's a uranium, you want to make it, whole thing is a PB. So you need to know the time taken is how long, so we can calculate. Okay, we can calculate is how long the time, whole the rock will become the PB. So the higher the duration, the older the rock. So if you find the time taken is longer, okay, you find the rock is older. So now this one's the info from the textbook. Radioactive material is usually they store inside the thick sealed container. Normally lah, we're using lead lah. Lead is better because lead they can block all the alpha, beta, gamma, don't come up, don't escape. So from here, this is one of the info you need to know. Radioactive, all the material must put inside the thick and also sealed container made of the lead safety purposes. Okay, radioactive isotope are the isotope with the unstable nuclei that can emit the radiation. So this one, radioactive isotope, they also will come on the radiation, alpha, beta, and also the gamma. So this all thing we need to keep properly inside the lid box. Okay, determine the half-life. Okay, from the graph, we can determine the half-life. Original is a 2000. When they just become the half, they become 1000. Okay, become half, there's a 1000. So you can see the graph. Now they show you already. When it just become 1000, the half-life is how long? This one is a 1 second. 1 second only. So from here, 2000 become 1000, we call half-life. So the half-life is a time taken for the radioactive to decay become half. So how long? 1 second only. So that means this one is a formula. So that's why I call you, don't memorize the formula. It's too complicated. Okay, we're just using our concept to understand what means of a half-life. So just show like this, 2000 become 1000. If I want to continue again, become 500. Okay, become 500, that means you're going to see the 500 how many? 2 seconds. Okay, so this one's another half-life. So we got 2 half-life become 500. 1 half-life is 1 second. 2 half-life, we write like this. So there's a 2 seconds. So we no need to memorize this one formula. Okay, so you want to memorize, okay lah, up to you lah, because sometimes students, they like to memorize the formula. So from here, the number of the radioactive nuclei that has not decayed, this one is still not yet decayed. Okay, so just now I say decay until 500. That means 500 is not yet decayed. Okay, but they do 1500, after they go 250, this one still not yet decayed. Okay, after you go to minus, before minus the last one, that means that one is already decayed. This one is what's the meaning lah for this one formula. Okay, so from here they explain for you what's the meaning for this one formula. Okay, you also need to know what's the physical quantity for every alphabet here. You cannot say, I don't want to using formula, I don't need to memorize. Okay, we still need to know. NO, what is that? NO is the original initial number of the radioactive nuclei, means 2000. 2000 is the original lah. Okay, half. Then N stand for what? N is a number of the half-life. This one. Just now I do 500, is it? Continue, 250. Here, how many half-life? 1, 2, 3. 3 half-life. So you put the N is a 3. Okay, and the last one is a half-life of the radioactive substance. Okay, 1 half-life is how long? 1 second. Then you just put 1 second. Okay, so from here, this one is a formula. And you want to find how many half-life. So 1 over 2, then small n is stand for the number of the half-life. Then this one is the original. Okay, so this one's a formula. Then I show you the easy way how to do the calculations. This one is the one of the concept let you to understand. Just now we're using the formula. Okay, initial, when starting not yet decay is a NO. Okay, the number of decay of the nuclei is 0. This one still not yet decay. This one is full. This one is nothing. So this one later will pass to you. Pass to you. So the half sudah hilang. Go where? Go here already lah. You 50% hilang, then 50% I give you already. So you can see orange color and white color. I have for you. Then another way, I decay again. I become 1 over 4. Then you take the rest lah. 3 over 4 you take already. Then I decay again, 1 over 8. Then 7 over 8 you take. And then you see continue. The orange color become less and less. Then the white color become more and more. The white color means already decay. Okay, the orange color is what you left. Okay, so this is what's the meaning for just now formula. Okay, now you can see the graph. The graph actually, we cannot say this one is a inversely proportional because inversely proportional like this, never touch one. This one got touching, but you can focus when they go to the x-axis, never touch zero. So that means the half-life cannot achieve until 0, 1. And they sure got 0.0000 something lah, but cannot achieve until 0. Because you divide by 2, divide by 2, divide by 2, they still got some readings. They cannot straightforward all until 0. No. They got still some, a little bit readings. So from here, this one we call first half-life, second, third. Okay, you can see the orange color and also the green color. Okay, orange color, when I achieve half, this one is my half-life, the time taken. This one, when I achieve the half of the green, this one is my time taken. So you can see this one, t + 1 half, sorry, smaller than the t 1/2. Because maybe this one 2, this one 4. That means you can see this one take 4 seconds, become half. Okay, for the orange color, take 2 seconds, become half. So which one faster to decay? Sure, it's the orange. 2 seconds already become half. Okay, the green color is 4 seconds, baru you become half. So the green color, maybe you take longer time to decay. Then the orange color, faster. Okay, 2 seconds, 2 seconds, 2 seconds. After that, slow, faster, finish. Okay, then we can see the explanation for here. The shorter the half-life, that means the shorter half-life means the orange color. Okay, of the radioactive, so you can find the higher the rate of decay. Higher the rate for decay means faster to finish. Okay, so from here we can find when the half-life is very short, means you faster to hilang. Okay, faster to finish all the things. Okay, so if they'll see the half-life is longer, 2 years, 3 years, so you are slowly, but you can finish. This one we what means of the half-life. Okay, now you can see example question. Okay, this example question I think not in your exercise. Yes or not? No. So you can refer here first. Later got question same like your exercise. Okay, so you can see PA that take 20.8 hours to shrink from 80 grams to 5 grams. Okay, so the first question they ask you, how many half-life are there? So 80 to 5. So we do by ourselves, don't using formula. Just 80 divided by 2, 40. Divide by 2, 20. Divide by 2, 10. Until 5, then we stop. So we're going to count. 1, 2, 3, 4. That means I got 4 half-life. Agree? So from here, they ask you, how many half-life are there? 4. You got 4. Okay? Then after that, the question say they take 20.8 hours from 80 to 5 grams. So that means 20.8 hours actually is a 4 half-life. Okay, now the question they ask you, 1 half-life is how long? So you take 20.8 divided by 4. Then we know 1 half-life is how long already. Okay, so this one is a calculation. Don't using formula. Okay, like this is more understanding. So I just show like this. 80, 40, 20, then until 5 we stop. So we go and count the half-life. 1, 2, 3, 4. I got 4 half-life. So I can answer number 1 already. Half-life, how many? 4. Okay, B, I want to find 1 half-life is how long? Because 4 half-life is 20.8 grams. Get it? Sorry, you're not gram. 20.8 hours. Hours. So from here, 1 half-life is how long? 1 half-life is 20.8 divided by 4. Final answer is 5.2 hours. Okay, example 2. Okay, example 2. You can see a sample of the lead 211 of the mass 96 grams. Okay, has the half-life. They tell you half-life already. Half-life is 36.1 minutes. Okay, what fraction of the sample has not decayed after this minute? not decay, that means left one. Okay, they want fraction. Okay, so I need to know 108.3 inside got how many half-line, because one half-line is a 36.1. So I need to divide, is it? I take 108.3 divide by 36.1. So I get it, suppose it's a 3 lah. Okay, I got 3 half-line. Suppose inside got 3 half-line. So they say original is 96. Okay, after 3 half-line is how many? So I need to show lah. Okay, info first. Okay, 96 is the ori. Half-line is 36.1. This one is from the question. So I need to show 36.1 to 108.3. I divide, I get 3 half-line. So from here, 3 half-line, that means I need to show how to do the 3 half-line. Okay, original 1/1 become 1/2, become 1/4, 1/8. Okay, this one is a 3 half-line, is it? Okay, so from here, I can show the fraction is 1/8. If not, you can do like this. 96 gram divided by 2. How many? 96 divided by 2. Okay, 48. Okay, again. 48 divided by 2. 24. Okay, now only 2 half-line. Continue. Then become 12. Okay, so from here, I'm going to take the fraction. 12 over 96. So make it become the shortest one, the smallest one. So 96 divided by 12, 8. So they become 1/8. This one is the fraction after decay for 108.3 minutes. Okay, excuse me. So this one is a fraction, still not yet decay. There's a 1/8. Normally, we need to write the lowest for the fraction. Don't write 12 over 96. Okay, you can do like this. You also can do like this. Because ori 96 sure is a 1/1. Okay, then 1/2, 1/4, 1/8. So until 1/8, there's a 3 half-line, then we stop. So we know this one is the last one. The fraction is left how many? 1/8 is left. 7/8 already decay. This one is a meaning. Okay, then we go B. What is the mass of the decay produced after this period? So you can see B, they asked about this one. Just now I show one. So the B is, okay, mass decay products is what? 1/8 the 96. Suppose it's a 12 gram, no? That means the 12 gram is left one. Okay, this one is the left one. Okay, the question asks you, products after this period of the time. Okay, this one is the mass or decay products. Okay, if they ask not yet decay, also same decay product. If they say already decay, then you need to take 96, go to minus 12. That one is already decay. Okay, number 3, refer the graph. Okay, what is the half-line of the sample? Okay, we got to ask the student to answer it. Okay, 25. So half-line, you need to see the bottom one. Don't see the activity. So half-line means the object original, they become half. So you can see from here, when original is 1,006. Okay, after that, they become half, means they become 800 lah. So when they become 800, it's how long? 25 minutes. They take 25 minutes. So from here, the half-line of the sample, they become 800. Then after that, the half-line, the time taken is 25 minutes. So from the graph, we can find all the things. So the first one, half-line is 25 minutes. Okay, so we show this one. Half-line is 25 minutes. So what's the half-line of the sample? State the value of the T. Now T is how many? Okay, T, we can see 200. So that means 1,006, 800, 400 become 200. Okay, we got 1, 2, 3. 3 half-line. So what you think about the T? So I cannot say 25 times 3. Okay, I can say 25 times 3 or not. Actually cannot, because you start from the 0. So I just put 3 half-line. So I take 3 multiply 25. If they never start from 0, cannot. It start from 25. That means you know minus 25. But the question start from 0, can. You straightforward take 25, multiply 3. So the answer is 75 minutes. This one is 75 minutes. Okay. So if the question start from 0 lah, because 0, 25, then continue. If the question start from 25, that means you need to minus the 25. Okay, so this one is the question for example 3. Okay, example 4. Example 4. Okay, example 4. Okay, a sample of the radioactive material. Example 5, that one from your notes. A sample of the radioactive material is stored in the lab. Okay, has an initial activity. Initial means starting. Starting is a 480 per second. Okay, if the half-life is a 6 minutes, they tell you the half-life already. 6 minutes. How much the activity after 30 minutes? 30 minutes, that means how many half-life? You need to divide lah. 30 divided by 6 lah. So I got 5 half-life. Okay, 5 half-life. So from here, they ask you how much the activity. I mean the 480 after 5 half-life. Then we left how many? Okay, so you go to show. This one is an info. Ori 480, half-life 6 minutes. Then they give you the total time taken is 30 minutes. So they ask you finally the left how many activity. Okay, just now got people show me answer, is it? Okay, we're going to show 6 minutes to 30 minutes. So you got 5 half-life. So you're going to show one by one. 480, 240. Finally, after 5 half-life, I left how many? 50. So my answer is activity after 30 minutes. That's a 15 per second. That's all. Okay, we don't have any calculation for the formula. It's straightforward, one by one, put the arrow. Then after 5 half-life, okay, I stop already. So this one is a 15 per second. That's a what? Not yet decay. Okay, so this is a simple question. Okay, this one is your example 6. Example 6. Okay, the radioactive material the store in the lab has a half-life 10 days. They give you a half-life 10 days. Calculate the number of the day taken for the activity of the sample radioactive to reduce to. That means Ori is 100%. I want you to reduce until 25%. This one is a meaning. They ask you how many days. Then will become 25%. Okay, so info. Okay, Ori 100%. Half-life is a 10 days. Then do know the total time half-life. Then I know final I want 25%. So I need to show 100 to 25. I got how many half-life? 2 half-life. Okay, 2 half-life. So from here, if 2 half-life, that means I need to multiply 2 lah. 10 days is a 1 half-life. Now I need 2 half-life. So I just number of the day to taken. There's a 2 times that. That's a 20 days. So that means the question, the explanation is they take 20 days from the original 100% to become 25%. So the decay lah, do the radioactive decay until 25%, they take 20 days. This one we call half-life. Okay, simple question again. Then we go to the 7. The question from 7, a little bit complicated. Okay, so the ratio of the nuclei for the argon is 40. They want to become the potassium 40 in a sample of the volcanic rock. There's a 3:1. 3:1, the ratio. Argon, they want 3. Then potassium 1 become 1. Okay, in the earlier formation of the rock, there was no argon element. That means when starting, argon is 0. Okay, trapped in the if the potassium 40 decay to argon with the half-life, 1 half-life already is 1,250 million years. Then estimate the age of the rock. So that means when starting, argon is 0. Potassium is 4. Okay, so I want to give you until 3:1. How long? The half-life is how many first? You need to find out the half-life is how many. Baru I need to multiply 1,250. Okay, so this one is a process. Now we're going to show argon when starting, argon to potassium. Finally, I want 3:1. Potassium 40 to argon. So that means half-life is a 1,250. This one is from the question. So from here, when starting NO, half 1 over 4. So potassium, I want to left become 4 only. Because we got 4, 0, 4. So finally, I want 1 over 4 from the NO. So from here, NO half 3 over 4. So this one's the argon. Argon, finally, they want 3 over 4. Okay, potassium, I want 1 over 4. So original become half. I get 1 over 4. So this one become half. This one is left. This one left. This one you gain. You gain from the potassium. So that means 1 over 2. Then if this one become 1 over 4, that means you get 3 over 4 lah. So this one is ori 0. This one is a 1. So they become 1 over 2. This one also 1 over 2 lah, because they give you already. So this one become 1 over 4. Then they give you how many? 3 over 4. Okay. So you can see this one not half-life. This one not the pattern for half-life. This one, yes. This one, the second one is the pattern from the potassium give to argon. 3 over 4. Okay. This one you cannot say, oh, 1 over 2, then 1 over 4. No. 3 over 4, this one is come from the potassium. Okay. So case 1, yes, we follow the half-life, the procedure. Case 2, the procedure is get from the potassium. So original, this one is 1, this one is 0. So this one, when it become half, okay, the half you pass to the argon already. When you become 1 over 4, then the rest you pass to the argon. So the argon you get 3 over 4. Okay, so from here we continue to show. So the ratio now become 3, 1 already lah. 3 is for the argon, 1 is for the potassium. Okay, so from here, how many half-life you do become like this? Okay, you see the potassium. First half-life, second half-life. Second half-life, you already give the argon 3 over 4. So that means the whole process only take 2 half-life. Okay, understand? So from here, I can show how to do the calculation. 2 half-life means 2 multiply 1250. And finally, that's take 2,500 million years. Then you make the argon get 3 from the potassium. So that means just now the same like the rock lah. The rock when starting got uranium. After that, you want to decay how many times? Let another rock become left only plumber PB. So they do so many times the decay. Finally, they find the years is very wrong. 2,500. So that means this one also same lah. When starting, this one is what? The rock. They don't have any potassium. They only got argon. Argon is a 0 inside there. Don't have any potassium. Then the potassium want to pass to the argon. So the one half-life already is a 1,250 years. Now I want to pass the potassium to the argon until 3 ratio. That means the argon want to take 3 part from the potassium. So they need to take 2 half-life. So when they take 2 half-life, that means the years already is a 2,500 years. So the question for the half-life, not only for number, they can come out in fraction. They can come out for ratio. They also come out from percentage, also can. So you must remember when starting the initial, if they ask about the percentage, sure is 100%. If they want you to use the fraction, sure is a 1 over 1. That one is the original. Okay, if they give you a number, then better lah. If they give you 40 gram, then better. 40 gram is a full one. Then you continue to be decay. Okay, so this one is example 7 from your question. Actually, from your textbook also got lah, the same question. Okay, then we go to the 7, example 7. That one is your question is what? The question is your question solving problem half-life, question 1. The rest one you do by yourself. I give you the answer first, like example 8. You got example 8, is it from the notes? The example 8, the answer is a 64 hour. 64 hours. 64 for example 8. Okay, 64 hours. Okay, example 9. The answer is a 50 minutes. Okay, you're going to check. So now I want to go is as question number 1, solving problem involving the half-life. Okay, you can see this one table. This one is a table. They show you the date. They can come out a question like this. 1st February until 21st February. Okay, actually inside how many days? 21 days. Okay, 21 days. Okay, when starting the activity, this one. Okay, after 21 days, they become this one. They ask you determine the half-life. So from here, you decay half and half. So I need to show February 1st to 21st February, there's a 21 days. Then after that, I need to divide by 2. Okay, I take the first one original, divide by 2, until stop here. So I got how many half-life? 3 half-life. Okay, 1 half-life is how many? Because I know there's a 21 days. The whole process 21 days. So 21 need to divide by 3. Okay, 3 half-life is take 21 days. So 1 half-life is 7 days. Okay, question number 2, the radioactive element with the mass. Okay, original, the mass is a 12 gram. Half-life 5 days. So we write the info lah. Okay, then they say what is the ratio of the mass 10 days before and after. Before, so you can see original you are 12 gram. Before 10 days. So 10 days means 2 half-life. 1 half-life, 2 half-life. So 1 half-life become 24 lah. Okay, times 2 again 48 lah. This one is a before 2 half-life. After 2 half-life, 6 lah. Again 3 lah. So they want to find the ratio 48 and 3. Okay, this one is what they want to do. So from here we just show half-life is 5 days. 10 days means 2 half-life. So I need to show 2 half-life before. That's a 48. Okay, 2 half-life after 3. So the ratio how to put? So the ratio is 48 to 3 lah. So I make it become the smallest number. So it's 16 ratio 1. Okay, so this one is the answer. The question just asked about the ratio. Okay, then we go to number 9. Between a period of the 60 days. Okay, 7/8. Okay, of the original number of the radioactive atom sample has decayed. Ini sudah decay. How many not yet decay?
1/8.
Yeah, 1/8. So that means finally 1/8 is the left one. Okay, 7/8 sudah hilang. Okay, so they ask you what is the half-life of the sample. So that means original sure is a 8/8 law, is it? So from here they ask between 16 days. Use the 60 days. They make it become 1/8. So you need to show the procedure lah. So this one info first. Original 8/8 100%. 60 days they make it become 7/8. So the left how many? 1/8 only lah. Okay, you can using percent, you can using fraction also can. Okay, if I using percent, that means 100%. I want to make until 12.5%. So I divide lah 100 become 12.5. If not, you can take 8, 1 become 1/2, become 1/4, become 1/8. Then I stop already. So 1, 2, 3, 3 half-life. Okay, 3 half-life. The what the question come out already. Wait, later do because you code I know you give you full you cannot do one. Okay, so from here you can see 3 half-life. 3 half-life they're using 60 days. So 1 half-life is how long? So you just go to answer. 3 is a 60 divided by 3, 20 days. Okay, the half-life only is 20 days. Okay, so from here, actually there's a finish. So what you need to do is a 6.1, the formative practice from the textbook. Only got, don't know, 3 or 2 questions only like this lah. Just copy the question in the foolscap paper and do it. Okay, I need to go for your exercise already, your tutorial. Okay, so we finished the lesson. Thank you, everyone.
Thank you, teacher.
Okay, bye.
Thank you, teacher.
Bye.
บ๊ายบาย